Hello Sim Gamers and welcome to another episode of Let's Play hackmud. In the previous episode, or episodes, we figured out how to find public corporations that we can penetrate to gain access to a list of dead or derelict accounts that we can then pop to gain loot, like money and upgrades. We're not initiated yet, so we're not getting any upgrades ourselves. But if I check my balance, you know, we're doing pretty good so far. Let me just toss it up on the screen here with the sys.specs. A little over 600,000 global currency, or GC. But cracking these things has been repetitive. It takes a lot of churning through well-known lists of information, like what the 3 commands for an easy 21 crack. And that this game gets a lot easier if you either run someone else's script that knows how to do this, or make your own script that can figure out how to do this on your behalf. So that's what we're going to take a look at today. So the first thing we're going to take a look at here are a couple of tools we can have available to help us practice our locks, but also do test runs of our candidate script against to see if it's performing how we expected without having to be in a hard line, cracking real NPCs all the time. There are a few of them out there. They are called, generically called lock simulators. The one I'm going to be using is called dtr.t1_lock_sim. As usual, before running anything, let's see what we're getting ourselves into. Not scripts.fullsec, I want scripts get level. dtr.t1_lock_sim. And it does say it's a full sec script. So if I run it with the default parameters, it'll create a random set of locks to simulate. And then if I run it with the empty set of parameters, it'll behave exactly like an NPC lock. And it's saying, hey, we need to solve this with C001. So we could run this like a regular lock, go through it. The next thing we need to solve is an easy 35. So you can see how this is simulating an existing lock that we want to solve, but we want to start doing this with automation. And the entry-level automation we can do is tackling some of those easy underscore locks. So let's go ahead and one. And now we have our expected behavior here, DTR T1 lock sim. It'll say we need an easy 21 to do it. Open, and it opened, right? And we could run it again, and maybe this time we get a different command. It says open is not the right one, so we can go ahead and release. But as you can see, this is getting repetitive, and we need to run through a list of stuff in order to solve. So that's what we're going to do with the custom script we're going to build. So the first command we run here that's going to help us with the scripting is #help. This is where we go to manage all of our scripts, both for our user in the system, but also kind of get access to them on or set up a boilerplate copy on our local system. So I'm going to use the edit command to edit a new script called easy crack. It doesn't exist, so this command has actually created it on my folder. If I bring it up in my Visual Studio here, we can see that it's created this sort of boilerplate JavaScript function. JavaScript is the programming language that runs all of your scripts on hackmud. So here we have this boilerplate. All it's doing is it's getting our caller from the context. It's instantiating the standard library, and then returning this object which contains OK false. Let's see what that looks like when we run it on the server. Before we do so, we have to actually upload it. And now we can run this script just like any other. So this is telling us we've successfully uploaded it. Its security level is 4, which is the same as full sec. It's used 89 of 500 characters and is not public. By default, any new character, even if they're uninitiated in the mud, has a single script slot with 500 characters available that cannot be public by default. So let's run it and see what we get. simgamer.easycrack. It just says failure. Now, if we really wanted to, we could get level our new script, of course. simgamer.easycrack. And it says it's full sec. And the other thing we can run is get access level, and it says it's a private script. That means no one else can access it except for this user in the system. The next thing we're going to take a look at is what's called a scripter, which allows us to which will allow us to pass in another script that we want to run within our own script. So let's take a look at how to do that in the Visual Studio. All we're going to do here is return, instead of return OK false, we're going to wipe that line out and return args.t.call args. And let me go through what this is actually doing for us. We're grabbing the arguments that were passed in. Those are just like any other script that we've run before. These are the things that are inside the curly brackets. We're going to grab the t parameter and we're going to call that. So we're saying that we expect this to be a scripter of some kind in order to actually run and call that. So let's save this, upload it, easy crack. And then we'll go ahead and run it against, like we need to provide the t parameter, .dtr.t1 locksim. So we're running my script, my private script I've created. We're passing in the parameter t, and we're saying, for this parameter, use this scripter to run this other script that exists in the system and is public, or at least is accessible by me. See what happens when we run that. It says, lock error, denied access by Halpern Systems, easy21. It's as though we had just directly ran this script, but now we actually have access to do stuff with this scripter, or this destination, in our script. And let's take a look at what that looks like. One thing we want to take a look at before doing that, though, is we do want to double check what happens if we run this without any parameters. We get an error. It says it cannot read property t of null. And if we run it with an empty set of parameters, it says cannot read property call of undefined. So that's something that we want to fix really quick. In order to do that, back in Visual Studio, I'm actually doing the following. First of all, I know that I'm not using these in the script, and they're just taking up characters that I'm not using. So if I comment them out, or even better, completely delete them, then I don't need to worry about them. But what we're going to do right here first, we're going to go ahead and check for missing parameters. Comments like these don't take up any character space in your script, so you can comment away and not have to worry about using up your precious few characters that you have to begin with. Here's how we check for the parameters that we need to have in our script. We know that we require this args. So if we say not args, this is a fancy way of saying if the args don't exist, or not args.t, if we're missing our arguments, or that's what the symbol means, we're missing the t parameter in our arguments, then we're going to return a little helpful error here. False. Message. And we'll just say t something like s dot target dot lock missing. And what this does, it will clue us into the fact, once we go back over to hackmud, if we upload this, that if we run it with our empty set of parameters, it says, hey, You're missing this required argument. I can't proceed. Some other optimizations we can actually do here really quick to save us characters. Context is cool and all, but we can actually take this and rename it to _C. And we can rename our args to _A. I mean, actually rename the symbol. And that saves us a few characters. We'll go ahead and save that. We just know that _C is our context, _A is our characters, and we're returning this information. The next thing we want to do is take a look at singling out the lock error that we receive from all this text that we get in the MUD. So here we're seeing when we run this correctly, we get lock error, denied access by Halperian Systems Easy21 lock. As locks get bigger and bigger, we'll have to pick out the specific piece of information that we need. And right now, all I need is this last line of text coming from the lock. Or another way to put it is the last line of text coming from the output of this script. Here's how we're going to do that. We're going to go ahead and make an initial call to the target. And then we're going to split out the last line of text. Okay. First things first, we're going to let R equal a.t.call. Basically the stuff that we did down below, right? And I'm spacing my parentheses and stuff for a little bit easier readability. Now, we're going to let, oops, wrong spot. I have the comment here. We're going to let E equal r.split. Don't worry, we'll go over what all this means in just a bit. Open bracket, r.split again. Dot length, -1. Okay. And then we're actually going to return E here. So here's what's happening. Instead of returning the call directly that we're making, we're going to store that call, the results of that call, or the output of that call in this variable called R. Then in this variable called E, we're gonna do some string work on the string, or the output of this, of R, to basically split it into its parts. The first part, .split, splits the whole string into multiple strings, or an array of strings, broken on this \n character. That's the escape character for new line. So every time you hit return, the computer program, or the hackmud, interprets it as \n. Then we're going to look for this bracket here. Basically tells us, so at this point right here, when this split succeeds, I've created an array of individual lines. Now we're going to look at a particular element in the array, which is what this bracket means. It says, look at this element. I want to find, if I have an array of 5 items, I want to display the third thing, perhaps. In this case, I'm saying I want to display the last item. Arrays begin their first index at 0, so that's why the -1 is here at the end. But we're saying, do another split on this string again, and then tell me the length. How long is that string? Or how long is that array? In this case, it would be an array of 2 elements, which would be element 0 and element 1. Then we say -1 because I want to get the last one, which is going to be element 1. I take that value, stuff it in these brackets, and then we end up with this E. So let's go ahead and save that, upload it, and run it. There we go. Now we're seeing just the last line of text. The next thing we're going to actually work on, now that we have the last line of text, we identified that this is in fact an Easy21 lock, is how to solve it. So if we have an easy21, solve it. Here's what we're going to check. We're going to do another conditional. If whatever in the parentheses is true, then do some work. If e.includes, and includes is a function that we can run against strings to ask the computer, does this string include this value? And the value we're looking for is easy21. Recall back on the hackmud screen. If we have denied access by Halperion Systems easy21 lock, we know what kind of lock we're dealing with. So we're going to take a look at that and resolve it. Then we have these curly braces, and this is just saying we're breaking out a section of code that we're going to run if this condition is true. First thing we need to do is let's get our dictionary of answers going. I mistakenly hit the enter key too long. Release. Unload. So what I'm doing here is I'm defining an array of 3 elements, and the elements in this array are going to be open, release, and unload, the strings. We're going to call that array easy. Now we're going to go through each possible solution. And for that we run a for loop. For let C of easy, and I'm using a single letter here to indicate this is my candidate solution. And this is JavaScript's way of saying for each element in the array called C, I want to do some work with that element. Now, we already have arguments passed in. We can use those same arguments and pass them and include them in our call. So this is the same as the arguments that we're passing into here. And here's the arguments that we're going to use. So we're just going to say easy21 equals C. In programming language, this is the same as us saying, running this and saying easy21 colon whatever our value is that we want. This is how this is done in code, right there. Set this property or this object field equal to the value C, which is one of these ones from the easy list. Now, we repeat the call. We already have this R variable that we can reuse. So I'm going to say R for response equals essentially this line again without the let part. We don't need to say let again because we're already using that variable name in this scope. So we make the call with our new arguments. This argument now includes right here, easy21 equals C. And we're going to once again split out that thing and check something. Check to see if we solved it. If E equals. Double equals means if they're the same, or if I should say if their value is the same is more accurate. There are some nuances with that in JavaScript, but we don't need to worry about that right now. What we're saying right here is if the sort of error that we received or the message that we received is equal to connection terminated, then we're done. We call a break to break out of the loop, and we can once again return E and be finished. So let's upload this and see how it runs. E.include is not a function, so we got a typo in here. E.includes is what we're looking for. and we get the string connection terminated, which probably means that we solved the lock. So if I just run this by myself, I'm curious, you know, we can check. I'm curious to see what the solution was. Easy21, open. Actually, we already know what the solution was. It was release, right? Because we haven't changed this lock setup. Yeah. So here's what a successful lock unlock looks like. And the very last line we can see is connection terminated. And that's what we put out right here. Now that's handy for a single lock, but what if we want to solve multiple types of locks? We know that Easy21 and Easy35 are very, very similar. But before we get into that, we do need to try a lock sim with multiple locks to see what it actually looks like here. And here's how we do that. We're going to specify this. First, we're going to say Easy21. And then Easy35. Now, if we run it, we're going to run into a different issue. It says unload is unload is not the correct unlock command. What happened is it cycled through all the commands and didn't find a solution. It ran into this Easy35 issue and continued executing. This should also be unlocked, by the way. That's a mistake. But here's how we're going to solve that. Notice that when we run this DTR lock sim, we know that the first lock is Easy21, so let's go ahead and try and crack our way through. Open is the correct command, but we're getting denied access by Halperion Lock's Easy35 system. In our program, we're looking for a connection terminated to determine if we solved the lock or not. Well, we never get this text because we solved the Easy21 lock, but we didn't solve the Easy35. So we get denied access by instead of unlock. So we're going to find a different condition to use to resolve that particular issue. Instead of saying, is this equal to this connection terminated, which may or may not be if there are other locks or other conditions happening, instead, let's say e.includes is not. Then we can break. And what this does is it says, it finds this. If open is not the correct unlock command, we are back in the program saying we have to continue doing work. We have to continue going through the list. So if we do not, if we include is not, that would be true if the lock has not been solved yet. So we're asking the opposite of that. Have we not solved this lock? Therefore, if we have solved this lock, we're going to break. So let's up that. Easy crack. And see what happens now when we run this lock sim. Forgot to save. So now it says we're denied access by the Halperion system's Easy35 lock. So we got an Easy21 solution out of the deal. Next, we're going to take a look at adding the Easy35 lock to our current capabilities. And it's very, very similar to what we have up here. If e.includes Easy35, because this time we're working on Easy35 lock. I'm just going to fix some formatting up here to be consistent. Then we do much the same thing. Declare this variable for let C of easy. This time we're doing the easy 35. 35 equals C. And everything else down here is the same as what we had before. So if we upload this, hypothetically speaking, we should have the next problem we need to solve, which is the digit. So we know that after the easy 35 is ran, and I'm going to do it inside this if, we're going to go through a set of digits. This requires another for loop. We're going to run a for loop over all the integers from 0 to 10. I less than 10. I plus plus. And here's what this for loop is saying. Start off with the number 0. As long as that number, start off at the number 0, I'm sorry, let. Start off on a number we're indicating as I at 0. If it's less than 10, do this work, and then when the work is done, increment the value by 1. So here's the body of work that we're going to do. We know that the parameter we need to pass is dot digit. Dot digit equals I. We'll repeat this call right here. And again, splitting out that response. And break out if we've solved it. Maximum character count of 592. Now this is where we start getting into character counts being our limiting factor. But we can work around that by the fact that a lot of this stuff that we're doing is actually quite repetitive. The problem is we're basically taking a list of items and running them over this for loop, which is pretty much identical in every single instance that we're running. The only thing that we're changing is the individual parameter, right? So I'm going to go to the bottom here and define what's called a function. I'm going to make the function call, and I'm just going to pass in, basically pass in A. And here's what we're going to do with that. We're going to make the call. Actually, I don't even need this A. I can get rid of that. Just function call. And the reason I can do this is because this parameter is part of this whole script. Everything, it belongs to, it's accessible to everything within these brackets. So we're just going to reuse that. That'll save us some characters. Let R. We're basically doing this. We're obfuscating out or calling out this repetitive piece of work that we're doing over and over and over again, so we don't have to repeat ourselves. In fact, I really don't need to do anything else other than to just copy this. In this case, we're going to go ahead and let R, because I want to keep R as a variable inside this function. And all we really need to do, we don't need to call it to a variable, we just need to return this value. So we make the call, store it in R, and then split out the value and return that value. Here's what we can do with this call now that we have it. Rather than repeatedly doing the thing here all the time, we can say E equals call, and that's it. We just saved ourselves a whole bunch of characters by repeating this call over and over again. We have further optimizations that we can do to really work on this. So the next step is getting rid of this repetitive digits call and making it also rely on the this call mechanism. And once again, we have some repeated information that we're doing here. Basically, we're saying make a list, make it a couple times, and then run it. What happens if instead of putting it down here, we declare it at the top of our function with a variable? A variable makes this piece of information usable throughout the entire library of code. So if we get rid of those two things, that gets us under our limit, just barely, of able to run this locksim. And we're getting connection terminated, which means we are successfully cracking EZ21 and EZ35. Now there is a method to even make this more efficient, which will give us more space to work with as we continue on. Again, we have some repetitive stuff happening. We're making the call and we're checking to see if it includes this is not sort of break situation. Why not do all that work in here? Why not do all that work in here or in another function to sort of merge these things together? Oh, also right here, actually. We forgot that we can make this call at the very beginning. Same thing's happening right here. So we're going to go ahead and just rather than those two things, we can let E equal our call that we're making down below. And that will save us even more characters. Connection terminated, everything's working as expected. So I'm going to define another function now to get even more efficient called crack. I'll use CRK to be a little bit of a shorthand to save a character or two, because this is going to get called over and over and over again. And here's how crack works for us. We want to pass in some information. So right about here is where I really want to try and call crack to solve it. I want to see we get the initial error. I want to see if here's how I want to use this function. I want to call crack with the following parameters. I want to call it with the type of lock that I'm trying to solve. And then I'm going to run it with the list of basically any array of values. In this case, we're going to use easy. I could just as easily have pasted this right in here, but that uses more characters. So we have this variable defined already. So here's what that's going to look like in a function to correctly run for us. We're going to say do a crack on L to designate the incoming lock that we've called, and the answers that we've provided. So E equals call. Sorry, getting ahead of myself here. Maybe this is right. E equals call if E dot includes this lock that we're working with, then we can do the body of work that we have essentially right here. For let C of answers. I can even go let A of answers. We'll set our parameter. Now, we don't know what type of lock it is here, but there is a different way to set this property. We can use this bracket and objects an individual object's property in JavaScript can be accessed with this bracket notation in addition to the dot notation similarly. So we're going to do the bracket with the name of the log. This says, take the string value that's in here and assign whatever that variable is the following value. We're going to assign it the answer that were provided out of the list of answers, or the current answer that we're trying out of the list of answers that we're doing. So set the parameter to the current guess. And we're going to repeat this call for each guess. Now E can come back out as call of A. So just like these calls up here, we're reusing this one. Now we have this crack mechanic. And the last thing we're going to do is inside this loop, if we get it right, break out. In this case, we're actually going to return from the loop. So if, once again, same condition, not e.includes. And this time, is not. Then we return E. Now there is a possibility that we get all the way down to the bottom here and the crack that we're running just doesn't exist. If that's the case, we're going to go ahead and return E down here as well. So this is just a safety. We're saying if this is true, then do all these things. But if we're entering this method calling easy21 and easy21 doesn't exist, then this whole block of text isn't going to happen, and we still want to return E. This if condition right here basically says if one of our answers that we provided, if the current answer we're working on is correct, stop answering the question, we're done, get out of here, and return back to the main loop. Now we have this method where we can say E equals crack easy21. And then we can go E equals crack easy 35, giving us those easy locks once again. And if we really wanted to go crazy, we could even say do the same thing for easy 40. Now we no longer need these block of texts right here. The only thing we still need to worry about is this digit. So what if we say E equals crack digit? Because we know that's going to come after an easy 35. But we need some digits to work with. So let's make it a new array right in here. 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all the answers that easy digit could possibly ask for. While we're at it, we're pretty confident this will work. Nothing could possibly go wrong. So we're going to see if this will work with easy prime. Easy prime. And here we're going to include the full list of known primes. I'm just going to go ahead and copy and paste what's in here. It'll be a whole lot easier than writing them in manually. But here are the list of known primes between 0 and 100. And like I said, we should be able to get rid of all of this now and potentially have this work for any of the easy scripts. We've reached our maximum character count of 501 characters. Here's another way we can actually save some room. We don't really need this message to be so verbose. We could just return OK false to say there is an error, and instead put the usage up here with a comment. Like so. Just double check this formatting. Might be a little bit of a formatting trick here. It should be giving me a helper. I wonder if it's because I have this stuff going on. Airline 6 illegal return statement. Now we're just really having fun. All right. Got to fix these little typos. SimGamer, there it is. So now it's giving us this helper to let us know that this is how you actually run the thing automatically. And that came from this little bit of comment up top. Remember, these comments don't take any character space in your script. But now we have a script that is potentially able to crack this target T1 lock sim. And there we go. It blew through an EZ21 and an EZ35 and gave us a connection terminated. I'm going to incorporate a little quality of life by, instead of saying return E, which is only the last line, I want to get a message out. So I'm going to put a message back into the parameters that are coming into the script and set that message to E and then return those parameters back out. This will look a little bit ugly, but it'll give us more information. So here's what it actually ended up doing. It said it ran EZ21 with open, EZ35 release, and digit 9, and then it says message connection terminated. Let's try it with the full set of locks that we know how to solve. EZ21, little typos here, comma, EZ35, EZ40. And here it was able to successfully solve all of those locks in succession, EZ21, EZ35, and EZ40. But we're going to run into a problem here relatively quickly. What happens if these locks are out of order? Let's throw an EZ35 up first and EZ21 at second and see what happens now. There we go. Got to run the script. You can see that it only unlocked the first lock and then denied access to us for that second lock. So we need to find a method to actually repeat this work over and over and over again until we know that we're done. So here's how we're going to propose to solve that. I'm going to declare another variable called C, and we'll just say it's true. I'm going to use C to indicate whether or not we continue this process over and over and over again. And I'm able to get away with very few. I don't have to declare var again because we can declare a list of variables, and because there's a comma at the end of the line, and JavaScript knows to look at the next line to continue declaring variables. So I could keep on declaring all sorts of other variables that I wanted to reuse. In fact, we can save ourselves a little bit of trouble by going down below our check and making this initial call. So variable declarations and initial call. Now we need to make a loop, a different kind of loop called a while loop. While continue, and since this is a true statement to begin with, we're saying continue equals true. While this is true, keep doing this body of work. By default, stop this loop. If the locks below are not found. So now we can specify a set of locks. So we're saying begin this body of work, immediately indicate the next time we come through we're going to stop unless told otherwise. And now we're going to do all of our easy locks inside this loop. In this case, E is a variable which is accessible throughout the entire script, so we don't need to pass it in. And we don't actually want to, we don't want to have E be the result anymore, because we're saying right here, set E to this call, and it sets this variable which is accessible throughout this entire range. What I want to get out of this method now is whether or not I should continue. Now we just need to go into the function here and make the logic. We really don't need this initial call. We're going to rely on the call from the last function, and it may very well just be the initial call to make this first determination. But instead of returning the message, we're going to return either true or we shouldn't need to return anything here. So what we're saying right here is we've begun solving this lock. We found that that this lock matches what you're asking us to solve. We've begun solving it. We've come up with a solution, which means we've solved at least one lock, but we're not yet sure if all of the locks are solved. So we're going to return back to the main while loop here and say C now indicates whether or not any of these things has resolved a lock. It starts off with false. It only becomes true when one of these locks has actually been solved. If it's true, that means we did some work and there's likely to be another lock to solve, so go back through and try again with all the other values. Keep doing that until all of these different lock types return false, indicating that we don't have any more work to do. Everything else is up to the user or the locks have been solved. So let's try it now. Some sort of issue happening here with our logic, so let's take a look. All right, after taking a look at this a little bit further, here is what I came up with. We want to check to see if we crack EZ35 before attempting to crack the digit portion. This is a shorthand way of saying if this is true, run a single line of code. So we're going to check that over here as well. So only if we actually solved EZ35 or EZ40 are we going to continue on and do the digit. And when that's true, then we'll come back through and realize that yes, we have more work to do. This is probably going to run over our character limit, so we have to do some optimizations to find just a handful of characters more. And we can actually do that by renaming some of our variables or finding other efficiencies. We're making this we're making this call to E all the time and then setting the message. What if instead of doing that, we just say a.m equals the call, and M will designate the message. So we'll no longer need to do this right here. Make the initial call. I had to move it down from the variable declaration because we're not declaring a variable, we're using an existing one. Now in here, A of answers. Actually, this is fine. This is going to be R. Because we're returning the last error message. The rest of the thing we need to call is this right here. We no longer need this E. So we're just going to check if A.M includes. Set that result to our call. Check to see if it includes is not and return false. Let's see if this solves our problem. That actually made it a little bit worse. So we need to find some more characters here. Let's rename some variables. Rename this to call. Rename this to crack, to CX, for short for crack. There we go, just under the limit. And let's see if this actually solves our problem. It did. So we're able to solve these locks in an arbitrary order. Let's go ahead and run our graduation ceremony here for this. And see if this actually does how we expect it to. So we're going to run things out of order intentionally. We'll go with an easy 21. Then an easy 40. Then the easy 35. And the reason I'm mixing up the order is because I know that logically my code is trying to look at these in this order, but really I want to be able to determine if we're able to run through this in an arbitrary order. Simulation created, let's run it. So here we go. Now we have all of these parameters coming out for all of the solutions that we just did. Let's throw in a real curveball and throw in C001, one of our favorite little locks, and see how the machine performs. Simulation created. It says the messages were denied access by Core 001 lock, but we got an answer out that we can reuse now. And we should now be able to start using this to manually put in the values that we have for C001. Yellow? Oh, no, I'm sorry. I didn't mean to read the message. Color digit was missing, so orange was correct. I know that the color digit from experience for orange is 6. And then it continues working and solves easy 35 for us. So once again, a quick take a look and a walkthrough of this last bit of code, and we'll run it through its final exam, a real world example of cracking something. So we set a list of our commands that we're going to run. We set a continue variable to true and made our initial call. We start up a loop to go through and make calls to each of these candidate locks. If we're solving easy 21, we get the continue out of that. If we're solving easy 35, we take the response from that to determine whether or not we need to go on and solve the digit. The same thing is going to be true for easy 40, where we need to solve an easy prime. Once any one of these things actually returns true, then we continue this loop until all of these things, all these conditions return false. If the return false is because either the lock has been solved or we ran into a parameter that we didn't know. So let's go find a corp to break into. Alright, sim gamers, we found ourselves weathernet.public's project archives for QW Stop, and we have a few candidates that we can crack into here with the use of our new script. Let's go hardline and see how it performs in the wild. (171-212-001-210). And we're popping into a hardline here. SimGamer, crack, plug in this anonymous thing that we found. And we found that the script did some work for us. It solved an easy 21 for us. So we're going to provide that information. And then we need to work our way through a C002. Which we do know how to solve with the right values. Lime is next, then green, then cyan, blue. Okay, that's correct. We need a complement. Complement. Blue, purple, red, orange, yellow. We fix this quote situation over here. Now we have a C003. Orange, yellow. Okay, now we're into some triads. Triad 1. Yellow. So it'd be lime, green, blue. And the color C003, not C001, C003. Triad 2 is going to be purple. Blue is not the yellow, lime, green, cyan. Cyan, not blue. So we can see this script is helping us a little bit, but it'd be better if we had room for the C00X series, but those take more characters than we have available. But this at least helps us get there quicker. Stick around as we hack through this, get this thing, get some money. I'll skip ahead and fast forward to having collected 1 million GC, and we'll get an upgrade and finish off the bulk of this script in less than 1,000 characters. Because what we've built right here is a really, really strong framework to expand on. Cyan is not even a color. Yellow, lime, green, cyan, blue? Isn't it blue then? Oh, I'm going the wrong way. This needs to be purple, and this needs to be cyan. There we go. And our script worked. We finally actually got paid. Let's go ahead and disconnect from here. But I want to take a quick look at some problems that we are going to run into. And that is in the flavor of something like this. If I go to make some locks, easy, 21. And then data check. Actually, we don't even need to do that. We can just say data check. Just the data check log. It's going to throw us a real problem. Data check V1. Yes, thank you, DTR. So let's run this against DTR.T1 locksim and see what issue we're going to run into. Denied access by the data check lock. So if we go data check, the problem is in this case we're only actually getting one of the 3 pieces of information we need for data check. Here's what it should look like when it comes out of a real lock. We get these 3 different answers. So we're going to have to figure out how to do that since this is giving us a different input than what we were expecting. And that's going to take some more work and some more characters to resolve. Very nice. As you can see here, I've made about 1.2 million GC working my way through these guys. And now it's time to look for some upgrades. So in order to expand my script, we're going to go browse the market. And the particular script we're looking for is called character count V1. Actually, I must have missed it. Market.browse. Anyway, the type is script space. Right? Yes. So we can look up here, public script, public script. Maybe it's not all uppercase, maybe it's lowercase. There we go. Chart count V1. Buy this nice cheap one. If we take a look at its details with the following command, put the key in the info, it tells us that this one's going to add about 500 characters. If I really wanted to, I could see if there's a higher rarity that I could afford. 500,000 credits for one of those. I'm not going to be able to afford that after I sysyn it, but we're going to go ahead and sysyn it up to the next level so we can actually add upgrades. This is required before you can, for the first time, before you can do any upgrades. It's going to cost me 1 million GC. Now I have 200,000 credits left. So we've got this ID up here. We're going to go ahead and go market.buy. Put in the ID. Man, I gotta be careful. Those typo squats could really get me. Confirm this purchase. One of these days, I'll get good at typing. I now have a character count script located, and if I actually check out my specs, now that I've initiated and I've loaded an upgrade, my information has changed. I'm now considered a weaver, and I have 1,000 characters of space. So we're going to come right back here after I've updated the script with everything necessary to run through all of those C00X scripts and give me a return for data check that doesn't suck. All right, as you can see, we got this thing. All right, as you can see, we got this script working. It will interrupt itself when it comes across a data check in whatever position in the lock it happens. So if I make, this is the lock set I did before, data check first and C001 after. So if I throw in like an easy 21 in the beginning of this, we can see that this script is now able to solve the easy 21 and then ask me for a data check. Which I have to solve myself because we just don't have enough script space for it at the moment. This is user teach provides instructions via script. In Trust via land, you encounter the will of Petra, the prover. And then safety depends on the use of scripts.get level. And it'll take this information we plugged in and continue on and solve 004 or 001, C001 for us. And we have connection terminated. Let's take a look at how we accomplish that in the final version of our script. So I plugged in all the information before, obviously, for all the C00 X's and their special handling. And I want to go over that really quick while we're here. Basically, if we solve a C001, then there's a little bit of special handling we do. The color digit is simply equal to the length of the value or the length of the string of the name of the color. So if it's red, it's 3, whatever. So that's what this does. It gets the length of the parameter that we passed in, and then we make that final call and exit this method. C002, it's going to find out where in this array of 8 colors the color the C002 color is, and then based on that, it's going to calculate what the complement should be and set the C002 complement equal to that color. Similarly with C003, finds the index of the correct answer that was guessed out of this array, and then sets the C001 triad, or triad 1 and triad 2 to the correct colors from that same array. And then special handling for data checks. Basically, this one's saying if we include, if our error response includes data check, we need to stop and prompt the user. So we're going to go ahead and put in the empty parameter or empty string for data check and make the call, and then return that call to the user. Now, if the user actually makes the data check call with empty quotes, which is exactly what's going to happen next, or they're going to put in the data check, if they put the data check in without an answer, then it will once again return and skip over this section. As soon as the user puts in a data check, neither of these conditions are true. This is no longer blank, and the error message won't include data check, so it's going to skip over this message and continue cracking other things in whatever order they appear. The only thing this thing can't handle right now, and we'll go ahead and run it really quick, is the locket. Again, this is a script space limitation with more, with another 500 characters, we could solve locket easily enough. It's a little bit of a complex script, or complex lock, much like data check. It takes a little bit of research to begin solving, and I'm going to leave that to you as a puzzle or mystery to resolve for yourselves. So with that said, I'm going to say, I'm Sim Gamer, and this has been hackmud.